So welcome back to another post bag. Heaven knows what number it is, but I was just going through some posts and I thought, well, I should probably record this because we haven't done one of these in a while. So some of these have already been opened and I'm just going to go through them. These are some ceramic tweezers. I bought these from a UK seller, so they were more expensive than they would normally be if you were to buy them from somewhere like AliExpress or from eBay China or whatever, you know, those kind of places. But these were £2.69 and let's just get these out. Now, the reason I picked these up, all of my tweezers are these sort of metallic ones, just all metallic with some kind of insulation stuff on the outside, and they are very magnetic. In fact, it's pulling this magnet thing off. And these ones, not so much. Stainless steel, and then on the end we've got ceramic tips. These are black ceramic ones. You can get white ones, or you can get white with black ceramic. You can get all kinds of different color combinations of these, but non-magnetic. And I'm hoping that might make it a bit easier when I'm doing some SMD work. Plus they're non-conductive too, so that's also an important thing to note. Might make it easier. They might not have components stick so easily. So I'm going to give these a go. I'm very used to these kinds, so it shouldn't be too much of a chore to use these instead. But yeah, £2.69 for those, not bad. I'll put a link in the description so you can find them. Next up, we've got this. Now, this is I think it says it's 14 centimeters. Not sure I've got the measurements on here to look at that, but 14 centimeter USB type B, female, to female USB type A. Now I've got this because it's panel mount. It looks like it probably has captive screws in there. Still, I got it as panel mount because I've got a little project I want to use for this to make it easily chargeable. Now the problem with making or modifying things and having them to be USB chargeable is mounting a USB charge hole, a socket. Like a micro USB socket, mounting one in there so that it stays there. And this seemed like it'd be a fairly good solution. So you just need a USB type B cable. I don't need a high charge current, so I'm not sure if these have a limitation, but 100 milliamps will be fine for me. So yeah, I've picked one of these up. It was £2.08. Again, I'll put a link in the description, but nice and useful little thing. It was originally, although the plan isn't using it anymore, was going to be for that rotary phone thing, and I was going to have it powered with 5 volts, and this would be sort of cut into the case and screwed in. But I don't need that anymore. I'm going to be using 12 volts for that, but this is going to be used for something else, and I'll show you that in a minute. Next up, we've got some little switches. Now they're similar to some other switches I used previously, but I bought these thinking they were through hole. Let's get some of them out. But they're not. They're SMD. Let's zoom in a little. So these are SMD switches. So they're meant to be mounted like this, horizontally onto the board, and then you've got a switch contact there. But I thought these looked like sort of through hole ones. I mean, they've got really long bits here. It just doesn't seem like there would be a problem if I made them through hole. So I might make them through hole. And the idea was that I would use it on a little dice that I have coming up. And I'll show you that now actually. So this is my little dice board and you can see through it essentially. You've got these holes here. Have I got a torch or anything here? No, I don't have a torch, but trust me, you can see through these bits here. So that's just the FR4 board. So I've taken off the solder mask and there's no copper there, so you can see through. So these would light up. And the idea is that you would shake it and a number would come up. And so I wanted a switch that would mount horizontally onto the bottom side of this board because it's going to have 2 sections separated by like a riser or something like that. This isn't the final PCB. I realized I don't want the little logo on there. In fact, I don't want any of those pins there. We're going to make it all sort of surface mount essentially, but the LEDs on here are actually going to be through-hole LEDs with the legs bent over. So square LEDs onto square see-through pads, essentially. So it should look quite nice. There's something else I've got that will go along with this, but we'll look at that in a second. So these switches were pretty cheap. They're MSK12D19 SMD single pole double throw switches. And although I thought they were through-hole ones, they are. They're SMD, and you get 25 for like 90 pence from AliExpress. So I'll put a link in the description. I picked these because you can find a footprint for them pretty easily. So that's why I've got those. But yeah, I bought 25. Next up, we've got something a bit strange. Now, if you recall, let's come out a little bit. We don't need to come out all that much, but if you recall, on a previous video, I looked at one of these, the CPT car power technology DC to DC converters, and I wanted to measure its efficiency. I had no doubt it was going to work for my project pretty much, but I wanted to see the efficiency. I don't need 3 amps. I probably need less than 2, probably an amp and a half for my Raspberry Pi 2 that I think is going in the rotary phone project. Anyhow, this one, the USB connector was broken on it, so I don't know if it's still around. I've probably binned it by now, but I need to replace it with something or go directly onto the headers on the Raspberry Pi, and I don't like the idea of that because it takes out the fuse, so there's no fuse in line when you're not using the USB. So I decided I want to use the USB. Not only is it cleaner, but I'm less likely to short stuff out if I'm still using the USB. Anyhow, you can pick these up. These are micro USB connectors, ports. What would you call them? I don't really know, but they're DIY micro USB plugs essentially. And I got 3 for £2.56 on UK eBay. You can get them internationally. I wanted them a bit quicker. Now let's come in a little bit closer and you can see these the connectors here. So you've got 2 on the top and 3 on the bottom. It's like a really weird sort of layout. So you don't have them all there, but I suppose the bigger the tracks, the easier it is to solder to. So one of the ones on the top there is 5 volts, I think, and then the one on the far side here is ground. I will sort of buzz it out and check, but that's what it is. So I can put these together, solder it up, and have myself a new little cable. I'm not going to put one together now. We'll make a video of that because it's going to be part of the rotary phone project, but yeah, I'm kind of excited about that. So another thing that I picked up is this TP4056 module. I picked up 2. Now again, I bought these from the UK, so they were more expensive than they should have been. These were £2.45 for 2 of them. And essentially they're lithium battery chargers, but they have protection circuitry built in. Now I've got a few batteries that I want to use and they don't have protection circuitry. They were pretty cheap. They're about 1000 milliamp hour capacity. And these boards are going to be ideal for that. Turns out I bought 10 of these and I've only just found them. So I bought these and I've opened them. So they're going in the post bag, but I think I did a post bag with 10 on previously, and they cost £1.76 from AliExpress. So you can get 10 for £1.76 and wait for the slow boat from China, or you can get them in the UK in a couple of days for £2.45. So that's what I did because I didn't know I had them. But these are going to be going in another project I'll tell you about in a second. In fact, I'll bring it on so you can have a look at it. But these are pretty cool. So USB charged as well. So I won't be using that. I'll be ripping that off. In fact, that's going to be coupled with this thing. So I'm going to cut the cable on here, put plus and minus into there, and that's going to be charging up my project. So we talked about this just now, which is going to be this little die or dice. I don't like saying die. It's going to be a little dice, and it's going to have 2 levels. I haven't designed the bottom level yet because I haven't figured out how I'm going to drive it, whether it's going to be done with Charlie plexing or the sort of preferred method that I want to use, which is an SN74HC595, which is a low voltage version of the 74HC595 shift register and an AT-Tiny85. But I need some way to trigger it. And so I picked up these. These are electronic shaking switch vibration sensors. You'll notice I picked them up a while ago and sort of forgot about them. But you get 10 here, so they're in this little packet. Let's get them out. Oh, well, there's one. One will have to do. So it's, in fact, it's probably easier if I draw this out, isn't it? Let's see if I've got a pen somewhere. So it's a tiny little thing. It looks a little bit like a capacitor, except for it, I'm drawing through a PCB. It has an outside case like that, and then on the outside of it we've got a big sort of thick conductor coming down, and that runs up into the tube like that. But we've also got a really thin wire coming out. It's a little bit longer than the thick conductor, and that comes in and it goes around. That's meant to be a spring, okay? It's not a very good spring. It goes around this thicker conductor on the inside, and when there's some vibration, that spring touches that larger conductor and will carry some current and voltage across it. So that's how you detect the vibration or a flick or whatever it might be. I'm hoping it will be the die being shaken like that, and then that will trigger it to give you a number, wake up from sleep mode or whatever it might be. Anyway, now that I've ripped this quite nicely, good quality UK ones. These were $2.99 delivered. So really, really cool little things. The code for these is SW18020P. Probably could have said that in a better way, but this was a bit ripped. So yeah, I'm looking forward to trying those out. They'll be a lot of fun, but that won't really happen until I start breadboarding up the circuit. All I've done so far with this is breadboard up some LEDs underneath it so that I could just see if it worked, if the concept worked, and it does. Hopefully I'll be able to put a little video here so you can see it working, or a picture maybe. Next up, we've got a box from LCSC. Now, I've not used these guys before, but I ordered some stuff from them and it was fairly cheap. It was a really good value stuff. And I ordered a lot because they're the kind of components I need a lot of. And so let's have a little look. Ooh, bit loud. So rather than show you the box, because it's not going to fit under the camera very well, I'll pull this out. So we've got a metric ton of 8-pin IC holders, IC sockets. So how many are meant to be here? 200. They make a really great noise, don't they? So I bought 200 of those. Let's find out how much they were. Oh, it doesn't say. I'll have to put it in the description, but they weren't expensive. They were pennies each. So it's a really great place to pick those up. These are going to be used for the crap cricket, which is probably around here somewhere. There's certainly one here. These are still going. That's the old crap cricket. There must be a new one. So there is. So the new crap cricket, which is this guy here, has these IC sockets on the back, and also something else which is in here has these little speakers on. Do we have a battery here that I can throw in this? Okay, I've got a battery. So I've got 50 of these boards. Well, probably 49 now. I've soldered one up, and hopefully this thing works. Oh, it does. So I've got 50 of those, and I bought 200 of these because I plan to add to the collection. Now there's a slight mistake on this blooming crap cricket, and I'll show it to you now. But I'm not overly worried. It doesn't look terrible, but there's a diode here, a diode symbol on the top layer. How frustrating is that? And I've got 50 of them done. Anyhow, the diode is there for if you want to charge it from external power so that you've got some reverse voltage protection, because they will be chainable. So if you wanted to make a little wall display of some of these, which might be hilarious, it might not be, then you could wire them together. Anyway, I put that there, and so if you want to use the battery power, you solder a jumper there. So that's why I bought all of those for this project and future ones. What else do we have in here? Okay. So these are for the dice, I think, or the die. Well, they are dice, aren't they? Whatever. So these are some different types of battery holders. Now, I have in the past used these. In fact, the same kind that's on the back of this cricket. They're very weird ones that I think people sometimes don't particularly like, but I like the footprint for them. I think they hold pretty well in the board, and it's easy to get the batteries out just by pushing that little bit there, and you can do it with your fingers. You don't need a pair of tweezers or anything. But I bought some of these. These are BS51s, I guess, is the manufacturer. CR2032 BS55-1 is the thing. I bought 55 of them because I want to try some out, and also I want 50 for the dice. So these are different. They mount vertically like that, and they have 3 connections at the bottom, 2 for positive and 1 for negative, and you just push a battery in. Let's see if I can just pop this battery out and have a little look at it. So positive this way, and you just push it in. Oh, that works really well, actually. So, okay, getting it out's not so easy. Okay, it is actually, if you just hold it the right way. Yeah, that's quite nice. I like that. So that will go inside the cube. The cube is going to be 40 millimeters tall by 40 millimeters wide. So essentially a cube like that. Do you remember I made that audio cube ages ago? That was a dice that could talk. And this one's just going to have like a visual display and potentially a beeping display too, so that if you don't have great eyesight, you can still hear what the number is. I don't know, we'll see. Let's pop these away. Again, these weren't very expensive, but I'll put a link in the description so you can take a look at them. And then lastly, in the LCSC box, we have these. These are, in fact, I've got some here that are basically sort of the same. They're slightly different form factor, but they are the same thing. These are PS1204, and these are tiny little piezo speakers. They're not buzzers, so they don't have an active component in there, like a fixed, I don't know what, 2K tone. These are just speakers, so you can ping them yourself with the tone library. Now they look really different actually to these, so I'll have to try them out, but they've got a slightly larger opening on the top. No, actually it looks the same, but they are smaller in profile, so they are to replace these ones that I can't get anymore. So in fact, the original ones were very different on the crap crickets, but I can't get these in large quantities. I can only get these ones, and they sound perfectly fine, so hopefully these ones will too. I bought 50 of those because I've already got a few, so we can play around with some of them. But yeah, it should be interesting. I'll put the link in the description for those as well. Again, they were quite cheap. Now last up, don't get too excited, although you could. This is going to be a present for a friend's child. He's 3 years old and he likes robots, and he wanted a robot that said Robot Master. So I said, okay, I'll make you a robot. And so I originally I had planned to 3D print one, but everything I made looked like it was going to break or he'd choke on it, or, you know, that kind of, I was too worried about anything that I could design and 3D print because he's already broken quite a few things that I've 3D printed. So I bought one and it's this little guy. This is the confused.com robot. Here is Brian the robot. I don't know if there's anything on here that says that. We'll just get him out, shall we? This is Brian the robot. So he's from their advertising campaign, and I don't have anything. I've never used confused.com, but it's like an insurance comparison thing, I think. Anyway, it's got a little number plate on the back, which I'm going to replace or paint over and put, the kid's name's Toby, so put that on. It takes some of these tiny little well, they're like these cells, like 3 of these or something, LR44 type. It's got a switch on the back and it's got a speaker and it talks with a button on the front. So let me play that for you now.
Hi, I'm Brian of Confused.com.
So he's already got a speaker in there and the grill is good enough for you to be able to hear it. And so I'm going to reuse some of the components.
I love being your robo friend.
So that sounds pretty good, I think. And he looks cool. Plus he's pull back and go. So it's got some movement to him. The body twists, the head twists and moves, and the arms move. I bought this secondhand. It was £6. So it's not like it was very expensive. I'm not going to be able to put a link to that. But I've seen online, there's a guy on Instructables, I'll put a link to that in the description, who had modified his one. And they'd made it so an ESP8266 would trigger him talking. But I don't want to trigger him talking. I want to use this button on the front to use the button on the front to trigger something else. And this is what I've been working on. So stay there, Brian. So this is my little board. Let's plug it in. So all I've done is picked up some samples.
Robot Master.
Off online. I used a robot voice creator and I'm using one of these serial MP3 players. They're like super simple. Plug a speaker in. I won't be using this one. I'll be using whatever's inside Brian there and then trigger it via serial. So I've got a few little samples in here and a button, which I'm going to replace with a button that's in Brian's chest.
Hello, Toby. I wonder what the moon tastes like. Twinkle, twinkle, little star. How I wonder what you are.
Okay.
Up above the world so high, like a diamond in the sky.
Okay, he's a little freaky, I admit, but all I've done with the button is say play the next track. And what I'm actually going to do is create a little array of the numbers of tracks that there are and create a randomly generated one.
Robot Master, hello Toby, I wonder what the moon tastes. Twinkle, twinkle, eat your vegetables.
Eat your vegetables. So that is the next project that I'm going to be working on because it's got to get done before Christmas. You do not want to disappoint a 3-year-old because they now remember things at that age, unfortunately. So he knows he's getting a little Brian. Well, he doesn't know what it looks like. He said he wanted a blue robot, but I'm hoping he's forgotten that. And if he does remember, there's some blue on here, isn't there? So that is what I'm working on at the moment. And this has been the post bag, I guess. So I will see you again next time.
Winner, winner, chicken